For this problem set, we're going to be looking at openings as well as insulation. So we will look at all of our exterior window and door openings, fill them out in this table. We will determine quantity of each, a description, simple description for each, the rough opening width, rough opening height, header length, and then the square footage of the opening. We will calculate the lineal footage of our headers, both the 2x header information as well as the spacer material, figure out how many sheets of the spacer material we need. Then we will look at our exterior perimeter to help us figure out what our insulation requirements will be. We will calculate the insulation both using the square foot method as well as the linear method, and we'll describe what each one of those are in depth. So what we're looking at in our Plan 100 are our door and windows. So our doors, we see that we have a front door that is 3 foot. We have a side door that is 2'8". We have windows around the exterior perimeter, and they're labeled with a letter and a circle around those letters. All of those correspond with the specifications that give us a rough opening width first and then height. A lot of times with window companies, you will see that the rough openings are more simplified, meaning it would be 5x4 or 7x5, something that is a little bit easier for the framers and not having to be so precise. And then the windows would be sized accordingly to those rough opening widths and heights. But it doesn't matter. They can be any rough opening size, but as long as they're given to you from the manufacturer specifications, it would make the calculation easy. So you may want to make sure you pull the numbers from the specifications. Also on Blackboard, we have the completed answer key for the sample problem. This already includes all of the information in our chart. So we have the list of each one of our numbers. We have the description of our front and side door and our A, B, C, and D windows. Simple descriptions, don't have to get any too far in depth. When it comes to the rough opening width and the height, as discussed in the lecture, we always have to add 2 inches to the width and 2 inches to the height of our door openings. So for our 3 foot front door and our 2'8" side door, we added 2 inches. And standard rough opening or standard door slab is 6'8", so therefore the standard rough opening height would be 6'10". When it comes to the rough opening of our windows, again, we just pull them directly from our specifications. We don't have to add anything to those. Our header length, again, as discussed, if our opening is less than 6 feet wide, we only have to add 3 inches. That's 2 studs, 1 on either side, so 1.5 inches times 2. That is where we get our 3 inches. So our 3'2" plus 3 gives us 3'5", also for our side door. Our A window and our C windows are all less than 6 feet, so we only add 3 inches. However, our B window and our D window are over 6 feet, so we need to add 6 inches. Our 7'5½", add 6 inches is 7'11½". Here we have to add 2 studs on either side, so 1.5 inches times 4 gives us the 6 inches, so that is 2 studs on either side of our header. Our opening square footage then is simply our rough opening width times our rough opening height, and those are all listed here in our table. So just a couple of notes to help explain how we got all of our numbers in our table. Remember, we're dealing with our exterior openings only in the sample problem, so we are not looking at any interior doors. For our doors, for our rough opening, both the width and the height, we need to add 2 inches to each. So add 2 inches to the width, add 2 inches to the height. Since they are less than 6 feet in width, we therefore add 3 inches, a stud on either side, for our header length. Our opening in the table is simply the rough opening width times our rough opening height. For our windows, again, we look at the window schedule. That is where we pull all of our rough opening width and height dimensions. We do not need to add anything to the dimensions that are given. For our headers, the A and C windows are less than 6 feet, so therefore we add 3 inches. Our B and D windows are greater than 6 feet, therefore we add 6 inches to the width of the rough opening to determine the header length. The opening square footage is determined the same way for the windows as it is for the doors. So now that we have all of our numbers, we can look at our lineal foot of headers, which is what we are trying to determine in problem number 1. So if we're looking at the header length, these are the numbers that we need to calculate our lineal foot of headers for the entire exterior openings. We can notice that we have the same length for our A windows and our C windows. Since it's the same, we can combine them. We can take our 1 A window and our 5 C windows and see that we have 6 total at the 5 foot 3.5 inches. And for our B windows and our D windows, those are the same as well, 1 of each, so we have 2 at the 7 foot 11.5 inch. If you want to write all of them out separately, that is perfectly fine. If you want to try and simplify it, that is acceptable as well. So we have our 3 foot 5, that is our front door. We have our 3 foot 1, that is our side door. Again, we have 6 at the 5 foot 3.5 inch. Those are the A and C windows. And then we have 2 at the 7 foot 11.5 inch. Those are the B and D windows. Total, that is 54 feet 2 inches. So when we're looking at our headers, as we discussed in class, headers are made up of 2 2x pieces of material So if we're looking at it in an isometric view, and then inside we have this spacer material that runs all the way the same length of the header. Doesn't matter what the header size is. For our sample problems, they are 2 by 8. So what that means is we have, for each of these thicknesses, 1.5 inch and 1.5 inch. That gives us a total of 3 inches. But if we're constructing a 2 by 4 wall, that 4 is actually 3.5 inches. So therefore, we need a 1/2 inch spacer material, and typically we use 1/2 inch plywood or 1/2 inch OSB, something that can fill the gap to ensure that we have the same width of header as we do as our wall. The height of the header will always be related to the second number, so since we have 2 by 8, that is actually 7.25. We'll need these numbers when we're doing our calculations. So number 2 is simply looking at the lineal foot of dimensional lumber, and we see we have 1 on this side, 2 on this side, so we can simply take our 54 foot 2 inch length that we just calculated in number 1 and multiply it by 2. And we know we need 108 feet 4 inches of our dimensional lumber 2x8s to make our headers. We purchase in board feet, so we can take our 2x8 over 12 to get a board foot factor of 1.33 repeating board feet per lineal foot, multiply by the 108 feet 4 inches, and we get 144.4 repeating. So we need to round up to the nearest whole board foot, so it's 145 board feet. We have our dimensional lumber. We can then calculate the square footage of our spacer material that we need. It is dependent upon the length, and the length we need to use was the one we found in number 1. It is the 54 feet 2 inches. It is not the 100 foot 4 inches. When it comes to our headers, for every 2 pieces of dimensional lumber, we only have 1 spacer. So however long of spacer material we need, it is simply 1 of those lengths, not 2 of those. We multiply by the height, that's the actual height, the 7.25 inches, and we get 32.7257, or I simply rounded it to 32.7 square feet. Number 5, we're determining how many sheets of plywood we need for the spacer material, and we know a standard sheet is 4x8, which is 32 square feet, so we're just over the amount for 1 square footage or 1 sheet of plywood. We cannot simply say we're going to use 1 and leave a little bit of spacer material out. Some practices might try and do that, but chances are as you cut the 1 sheet, you're not going to fit it all perfectly in. You're going to have some waste, so it will be a little bit more than just under square footage that you would need extra. So if we actually do the math, 32.7257 square feet divided by the 32 square feet that comes from a 4x8 sheet of plywood, 1.0227 rounds up to 2 sheets of plywood. And the last one we have to calculate for the first problem set is the square foot of openings. This comes from our table. So all we have to do is look back at our table, pull the numbers that we have from this column for our opening square footage. Make note that even though we had some header lengths that were the same when it comes to the 1 dimension, the square footage is different because when we have the height factored in, they are different heights. So we don't want to make the mistake of simply pulling 6 of the 23.53 when their C window is separate. So we need to look at our quantities. They're all singles except for the C window. We have 5 at the 19.33 square feet. So we can simply add those in. So again, these come from the table. We have the 21.64 from our front door, 19.36 for our side door, 23.53 for our A window, 34.81 for our B window, 5 of the 19.33 for our C windows, and our D window 30.46. Total gives us 226.42, which I've rounded up to 227 square feet, but since it is a square foot number, you can leave it in decimal. That is perfectly acceptable. So we'll need some of this information, including the square foot of openings for the second problem set when we're looking at our insulation, but that is how we factor in the board footage for our headers when we're doing our framing.